Good morning, everybody. We are live. It is May 18th. Not that that means anything to you, but if you're old like me, it means this is the day Mount St. Helens blew 40 years ago. Isn't that crazy? Wow. I remember. I was there. All of a sudden, the sky in the middle of the day got dark and ash started falling down on our heads. It was crazy. Anyway, back to math. So, if you have not done and finished up chapter 7, you got to get chapter 7 done, okay? Alright, so please get that done. I've been emailing parents. I can continue emailing parents. I don't want to get you in trouble. I just want you to get the job done, okay? I'll have another test 8, coming up on Wednesday, so we'll review tomorrow, and I'll get that out to you on Wednesday. And then we have a 3-day weekend coming up, and then we're almost done. We really are. We've got basically about 15 days left. And so we just have to finish up, okay? We've got one more really important chapter coming up, and that's on trigonometry, which we have to do, okay? So let's take a look at our homework real quickly from Friday. First of all, number one, these are not going to be similar because proportions don't work. And these two are. The ratio is either 2/5 or 5/2, depending on if you go from big to small or small to big. Number 3, x turns out to be -3. We actually did that one in our notes. 4, yeah, it's by side similarity, and the ratio is 7/3. 5, if you redraw it, if you just draw it, then you can go 6 goes to 15, and then you get the other two sides, 17.5 and 17.5, make that x. I just like to call it x instead of the ratio, so I'd go, for instance, 15 goes to 6, that's how I do it, 15 goes to 6, as x goes to 7, I would do it that way. And then for this one, I'd call this one maybe y, and I'd go, okay, same thing, I'd go 15 goes to 6 as y goes to 9. Again, I would draw another triangle, so then 6 has to go here according to what they told me. And then I would call this maybe x, and this is y, and I'd set up my ratios like x goes to 6, and 6 goes to 7, and I would solve it, okay? And then that's all you had to do. That was a pretty easy assignment. So today's notes, again, this is an easy chapter. Let's take a look at it. So, it is 5/18/2020. Our objective is to talk about triangle proportional theorem. So what we need to know is that if it's proportional, proportional is like saying it is the same, it's just size down, it's a scale of it. But when I think about proportional, I'm thinking about a fraction. Again, a fraction equal to a fraction. That's what I'm really thinking, okay? Because if two fractions are equal and in the same ratio, which means they're proportional, okay? Now, the triangle proportionality theorem says this. These two lines must be parallel. Must, okay? So you must, this is the must have parallel lines. Must have parallel lines for it to work out. Otherwise, it won't. So I have to be able to say that TU is parallel to QS. And if that's the case, let me make this easy and put some variables instead of letters. But let me just call this, say, maybe A, B, C, and D. Length, that's a length of A. So we can say A goes to B as C, whoops, as C goes to D. Okay. So if all we're going to do is set up these ratios, A goes to B as C goes to D, then let's take a look at example 1. Okay, they're parallel, which they need to be, and I can just set it up. I can say, we'll just leave it as QR, what the heck. We can go QR, or RQ, same thing, goes to 3 as 6 goes to 4. I'll say it again. This side goes to this side as this side goes to this side, okay? And if I want to solve for QR, well, that's easy. I'm just going to multiply by 3 to solve. Multiply by 3. Multiply by 3. And I'll get 18 over 4. So I'll get QR is equal to 18 over 4. Let's see, that's 9/2, 4.5. So the value of QR would have to be 4.5. Okay, and you could do that on your calculator if you don't believe me, but I think that's it. Okay, now This is the same thing. If we continue to make it into a circle, you get the same thing. So you can say that AB goes to BC. So we can say, okay, but they have to be parallel. They must be parallel. Have to be parallel, okay? So same thing. I can say AB, that's this side, goes to BC as DE goes to EF. Okay, there you go. So if I take a look at example 2 and I want to solve it, I can say that HG, that's what I want to solve for. Say HG goes to 120 as 300 goes to 150. Now I did this one where I put HG into, it's just much easier if you do what you want to find. You write down what you want to find first, because then solving it is really easy. So obviously you can see it's got to be twice as big, right? You agree? So it's got to be 240, but you can do the math. If we do the math, we'll multiply by 120, right? Multiply by 120. And if you try it on your calculator, you're gonna have to. You can see it's twice as big anyway. I know you can, because I know you're smart. But if you decide to do the math anyway, what's 300 times 120 divided by 150? Oops, 150. Yeah, what do you know? 240. Gosh almighty. I'm so smart. Yes, we all are. Okay, turn the page. So, we would do this in class, but since we're not in class, I'm going to do it. So, I want to bisect this angle, which we've done before. Okay, we've done this before. And we've used the compass. Do my little pokey. Okay, remember how I did this before? And I'm going to create a little point here, put my pokey there, right? My little pokey here, okay? And so if I were to draw in the bisector, which is what I want to do right now, okay, draw my bisector. Here is my bisector, which tells me that I've cut my angle in half, okay? Here's my bisector. Now, that's bisecting an angle, but what if this were a triangle? Let me finish up. I've bisected the angle. I know that this angle is equal or congruent to that angle. Okay? It has to be bisected. Then if I go back and I complete my triangle, okay, let me just draw my triangle in here. Well, again, I'm going to get a proportion, okay? Let me go ahead and make this side A, side B, C, and D, okay? So I can say this side of the triangle is equal to this leg, which is equal to this piece of the opposite side over this leg. So I'm going to rewrite it as A over B, A goes to B, A goes to B as C goes to D. Kind of unique how that works. Okay, so if I know that, then let's take a look at example 3. So here example 3 is we do have an angle bisector. Okay, if this angle is equal to this angle. So if I want to find TU, I'll set up the same thing. I'll go 14 goes to 24 as TU goes to 48. I like to write what I don't know first, makes it easier to solve. So I'm really going to write TU, the length of TU over 48 is equal to 14 over 24. And then again, the easiest way to solve for this is multiply both sides by 48. 48, right? Let's see, that's going to be 2. 2 times 14 is 28, and TU should be 28. Again, if you want to use your calculator, I knew that went in twice, times 14, but if you want to use your calculator, you can. You go 14 times 48 divided by 24, and you get an answer of about 28. Sure enough, what do you know? Okay, pretty easy day. So again, homework today is again easy. Homework's found on page 177, 1 through 9. I'll show that for you really quickly. 277 starts right there. Okay, and 1 through, and turn the page. 1 through 9. Super easy. I don't think I'll have any problems with it at all. Okay. All right, that's all I have, and get that into me.